All right, well, good morning, good afternoon, or good evening, depending on where you are in the world. I want to thank you for joining today's webinar session from Element 14 and Texas Instruments. Today, we're going to be talking about the third iteration of our Building Automation webinar series with Texas Instruments. This one is all about the user interface, and today we are joined by Pratham from Texas Instruments, and he's going to walk us through our presentation today. Now, if you have any questions throughout the course of the presentation, please feel free to either use the chat function or the Q&A window to ask those questions, and we'll make sure to have a live Q&A session at the end in which we'll address those. If you have any technical issues, you can't hear, can't see, anything related to Element 14 community, you can feel free to chat me directly at Premier Farnell Webinars using the chat function as well. So without further ado, I'm going to go on mute, and I'm going to turn it over to our presenter, Pratham, who's going to take us through a wonderful presentation. Take it away.
Great. Thank you. Hi, everyone. My name is Pratham Ramkumar, and I'm from MSP 430 marketing team at Texas Instruments. Today, I'm happy to share with you detailed information on how you can create robust, innovative, low-power HMI interfaces for various building automation applications with CapTIvate touch technology. So before I get started here, I want to share with you a brief video. Hopefully, this shows up okay in your application in your browser. If not, this video is also available online. But this is going to be a quick glimpse of what we're going to be talking about today. Yeah, hopefully you were able to see that video, and if not, the same video is available on www.ti.com/CapTIvate. Gives a very quick glimpse of the several features and benefits of CapTIvate that we'll go over right now, and also, so basically we'll go over some of the key benefits that you get with CapTIvate technology. We'll quickly go over CapTIvate technology, silicon tools, and ecosystem, and its applications that we are seeing good traction in with CapTIvate technology. And finally, we'll end with the summary and collateral information that we put together that you can view offline, and then Q&A. So moving forward, what is capacitive sensing? So capacitive sensing is using the principles of capacitance to use it in applications such as proximity sensing and buttons. So basically, you're saying you have a charged electrode of sorts built into your PCB, and you wave your hand near the PCB, and you're grounded. So you're changing the capacitance field associated, the E field associated with that electrode, and you're using that to determine whether a person is in contact with the electrode or not. You can actually use capacitive sensing in multiple ways. You can use it for proximity sensing and gesture recognition as well. Proximity sensing is basically detecting without touching, and gesture recognition is kind of taking it to the next step of proximity sensing, where you can actually wave your hand in front of a panel and have the MCU or the capacitive sensing technology manage it for you and read your gestures. So why are we talking about this? More and more building automation applications require sleek industrial designs. You want to have multiple overlays, be it glass or plastic or even metal. You want to have different shapes and sizes. And many times, with mechanical buttons, you have the issues of moving parts, and you have limited flexibility on what you can do with mechanical buttons. So we are able to eliminate mechanical buttons using capacitive touch technology, which is also very easy and clean to maintain. So we are seeing lots of applications, appliances, electronic locks, access control, thermostats, security systems. We'll talk a little bit more about the key features and benefits of CapTIvate, very specific to some applications in building automation on the slides later on. But I just want to make sure people understand what we're talking about is not touchscreen technology, but really what we're talking about is capacitive buttons. So think about the buttons that you would see on a microwave panel or an induction cooker or something like that. So why did we come up with this technology? So capacitive sensing is very cool. I mean, it allows you to make very differentiated user interfaces, but it does come with its own set of challenges. So what are the challenges? Noise. So having noise in your system, false triggers, looks like a capacitive button touch. So we went and solved that problem and also went one step ahead and built a full IEC 61000-4-6 certified solution for noise immunity. We'll go over what this certification is in the next slide. Versatility. So you need advanced interfaces. So people want to use metal overlays, they want to use glass overlays, they want to use plastic overlays. Ability to work with multiple overlays, ability to support 3D gestures, ability to work with gloves are very important for industrial designers, and versatility is one of the main features and advantages of CapTIvate technology. Power. In a mechanical button use case, you don't drain any power, whereas in a capacitive sensing use case, because you're building this E-field, you're constantly leaking power. So we actually have the industry's lowest power FRAM capacitive touch microcontroller, which operates at less than 5 microamp average power consumption. So this is actually the lowest power technology in the market. High resolution. So again, when you talk about ability to work with gloves, ability to work through thick material and overlays with air gaps, resolution becomes very important. So we are talking of a less than 10 femtofarad resolution capacitive touch solution here. Ease of use. This is actually a very, very important point. When you look at capacitive touch designs, usually, people are not experts in capacitive touch design when they start doing this stuff. And it requires a combination of electrical engineer, mechanical engineer, as well as maybe an industrial engineer to put this thing together. Well, we've done our best to try to make it easy, so easy that a hardware engineer with really no software expertise can go drag and drop sensors, tune the sensors, and get going in less than 5 minutes. So we'll talk a little bit about the CapTIvate Design Center here as well. First, let's get started talking about reliability. So as I mentioned before, when you have a conducted noise in a system, that can look like a touch. And this is a huge problem, especially for people that are doing wall-powered application. And the IEC came up with a standard called the IEC 61000-4-6 and IEC 61000-4-4 tests for conducted noise immunity or conducted noise testing. For instance, in the IEC 61000-4-6, they induce 10 volt RMS of noise into the system and check it for whether the buttons, A, not false trigger, and B, in the presence of so much of noise, is your hardware able to detect detect the button push. So we've been able to pass both these tests. In fact, we went and built up a whole system, went to a third-party lab, and got fully qualified for IEC 61000-4-6. There's another test called IEC 61000-4-4, which is for EFT, and we passed it at 4 kilovolts EFT, and a -4-2, which is an electrostatic discharge immunity test, which we passed at 8 kilovolts on contact and 15 kilovolts in air. So how do we do it? We have several features that are built into the chip, like frequency hopping techniques, zero crossing sync techniques, built into silicon for robust detection. We have several software techniques implemented in the silicon for oversampling, debouncing, and AC noise filtering. Overall, there are some system-level design requirements as well, which we have fully documented in this EMC compliance test report that we have put together. So in terms of reliability, the next major issue is moisture. Again, moisture, very much like noise, looks like a false detect. When you pour water on a charged electrode, it really looks like a touch. So we have several techniques, both from an electrode design standpoint, silicon, as well as software, to eliminate the presence of touch. So we have different techniques that we use, like guard channel approach. We also have a metal overlay, which we'll talk about in a little bit. Furthermore, when you talk about reliability, CapTIvate technology can also help reduce emissions. In most capacitive sensing solutions, you see the operating voltage is in the 3-volt range. So we are able to operate CapTIvate at 1.5 volts, thus reducing emissions in your system. Let's move on to versatility. So when we talk about versatility, we basically put a chip together that allows you to do various things with the same chip. So over here, we are talking about differentiated solutions with the metal touch. So so far, the popular ones for capacitive touch are glass and plastic overlays. We are able to actually go to metal overlays with CapTIvate. We are able to support up to 64 buttons over here with just 16 IOs. We have a technology called self-capacitance and mutual capacitance, and you can actually mix and match self-capacitance and mutual capacitance to do 64 buttons with just 16 IOs. Or you can mix and match it over here, where you're able to do 4 sliders, 4 wheels, 1 prox, and 32 buttons with 16 IOs. That's a lot of features, functionalities for just 16 IOs in your system. So what is self-capacitance and what is mutual capacitance and why is it important? So self-capacitance, you basically, just to get everybody on the same page, in capacitive sensing, you have a PCB and you literally put a copper trace over here. And on the copper trace, copper electrode, sorry, it emits an E field. And when a hand comes in proximity or contact with this E field, the microcontroller with the CapTIvate technology detects this change in capacitance and hence triggers a touch. So in self-capacitance, you just have one electrode and you have this E field emanating from there. And basically, that's self-cap. In mutual cap, you have 2 electrodes, a transmit and a receive, and you're looking at the E field between these 2 electrodes and the change in E field when a human body comes in contact with this. With CapTIvate technology, with a 16-touch I/O in self-cap mode, we can have 16 electrodes. Why is self-cap important? Self-cap is important because it can get you really high resolution sliders and wheels, and also a larger proximity distance. Mutual capacitance, on the other hand, with just 16 IOs, you can break them into 8 by 8, 8 transmit and 8 receives, and you can actually build a matrix of 64 buttons with just 16 IOs. Why is it important? It's important when you want to have a large number of buttons and you want to have tightly packed buttons, maybe a keypad, where you want to eliminate crosstalk. Also, mutual cap works better for moisture rejection as well. Both self-capacitance and mutual capacitance supports multi-touch. So basically, you can have 64 simultaneous touches on a keypad, for instance, with mutual cap, and 16 simultaneous touches on the self cap. With a hybrid solution, think about you're building maybe a control panel which illuminates when a person walks up to it, and then you want to have a large number of buttons when people actually want to enter an input. You can do that with CapTIvate technology because you can dedicate some of the buttons on CapTIvate technology with self-capacitance, and then you can dedicate some of the buttons for mutual capacitance. So you really don't need to trade off by either selecting self or mutual. You can mix and match the two. We briefly spoke about metal touch. Again, metal touch works slightly differently compared to plastic overlays and metal overlays. In metal touch, what we really are doing is you have a metal layer which is grounded, and you have the electrode built beneath the metal layer, and when somebody pushes the metal layer, the metal deflects, and we are measuring the change in capacitance between the metal layer and the sensor pad for you to trigger a touch or a no touch. Big advantages of metal touch because you're actually pushing it. It basically requires an actuation force, so it helps you with work through gloves and also ability to do force touch. So you can have multiple levels of force detected by the metal touch panel. And of course, the advantages are this is a completely sealed design, so it's waterproof, dustproof, and very, very resistant, and allows you to do very, very elegant user interfaces. Next, let's move to the low power advantage. As I mentioned before, capacitive sensing always has an E field, and you're constantly emitting energy. So what we have done is designed the technology from the ground up to minimize the use of power generating the E field. And here is how we do it. So if you look at a typical system where you have capacitive sensing, you have an electrode scan, and then you measure the change in capacitance. Then you do some level of processing to compensate for changes in environments such as heat and humidity, and also do noise filtering to eliminate some of the noise. And then you say whether the count that you measured here is above a particular threshold. And if it is above a particular threshold, you said, yes, a touch was detected, and you go process it. And otherwise, you just go back to measuring it over and over again. Well, in most of our competitor solutions, what you will find is the microcontroller would have to be active through all these things, both the yellows and the grays. What we have done with CapTIvate technology is the microcontroller just simply sets up the electrode, and the rest of the mechanism is handled by a hardware state machine. The hardware state machine measures and compensates and only wakes up the microcontroller when a touch event is recognized. Okay, so what does that get you? It gets you a very, very low power consumption. So we can operate at less than 5 microamps for up to 4 sensors, which are able to sense when the microcontroller is asleep. That also translates to 15 years of battery life on a single coin cell battery. And we also have 4 parallel electrodes, just not 1 electrode, but we have 4 parallel electrodes that scans during the wake on touch sleep mechanism. Okay, second point is from a low power standpoint, we are the world's only FRAM MCU with CapTIvate technology. What that means, what is FRAM? FRAM is a replacement to flash, non-volatile memory. Some of the advantages of FRAM is it has unlimited write endurance, it's 100 times faster than flash, and 250 times lower energy than flash. With all these advantages, you can really use FRAM like a data logging mechanism, or you can use FRAM instead of SRAM in your system. So many times you're not able to say that what is the difference, how much SRAM you need versus how much non-volatile memory you need. Well, you don't have to make that decision with FRAM because you can use FRAM like both SRAM as well as flash. In the context of CapTIvate technology, what FRAM allows you to do is do some data logging or maybe even state retention. For instance, if you have a thermostat and you have 5 different users in your house in your family, what you can do is you can have a user profile established for each one that can be changed unlimited number of times, and build up a smart sensor or smart ecosystem around this the touch feature. The next element is high resolution. So because of the high resolution, we can detect less than 10 femtofarads of changes, which allows you to do thicker glass design and also plastic overlays. You're able to do support for 3D gestures. By 3D gestures, I mean the initial video I showed a person waving their hand in front of the sensor, so you can get gestures like wave left, wave right, wave up, wave down using CapTIvate. And we can also have high proximity sensing distances with the CapTIvate technology. How are we able to do things like gesture recognition? Is because we can scan very fast because we have a hardware-based approach for capacitive sensing. And we also can scan 4 electrodes at the same time. So when you scan 4 electrodes at the same time, you can detect very fast-moving changes with very, very minimal CPU intervention. And that is really what you need when you have a system where you want to do gestures. So in terms of silicon tools and ecosystem, that's going to be our next topic. So we talk about CapTIvate technology. Let's talk a little bit about the device with CapTIvate technology. So the first devices to be launched with CapTIvate technology is the MSP430 FR253X and 263X devices. So there are four devices in this family. The 2532, which has 8K of FRAM and 1K of RAM, and the largest device has 16K of FRAM and 4K of RAM. There are also number of IOs, number of CapTIvate IOs is up to 16 CapTIvate IOs on the 2533 and 2633, and up to 8 CapTIvate IOs in the 2532 and 2632. Now, a couple of points here. What you're looking at is a completely dedicated peripheral for touch. This CapTIvate Touch, think about it as a smart ADC, for instance. So this is a completely dedicated and capacitive to digital converter. And then you have a fully programmable microcontroller right beside it. The microcontroller has a hardware multiplier. It has 2 UARTs in the SPI. It has a 10-bit ADC. It has a whole bunch of timers, up to 4 timers, and it has 16K of FRAM and 4K of SRAM. You see a 16K ROM segment over here too, and the ROM is basically the entire capacitive touch library, which goes hand in hand with the CapTIvate Touch peripheral. So the reason we committed it into ROM is A, for simplicity, so you don't have to worry about coding or do anything with it, and B, having the whole touch library in ROM allows you to do more with the amount of SRAM and SRAM on this device. So for instance, if you look at a competitor solution, you would find that you have to load the touch library into flash, which would take about 12 to 15K of flash. So it doesn't give you much room for your user application, whereas over here we are able to offload a lot of that into ROM and give you programmability with the SRAM available on this device. So we have 32-pin QFN and 24-pin QFN, and we are currently working on a chip scale package. It is actually a 2.2 by 2.2 millimeter package. So if you want small packages, we have a solution coming up, but the other packages are fully released to market today. So in terms of tools, this is the kit that we have. It's called the CapTIvate, MSP CapTIvate Development Kit. You can buy it from TI eStore or from Element 14 or any of our other distributors. It costs at 99 cents. It has the following boards. It has a board for self-capacitance, it has a board for mutual capacitance, and it has a board for proximity and gesture sensing. It has the MSP430 FR2633 PCB. This is the main processor, and it also has a programmer debugger, which allows you to connect to a PC and run CapTIvate Design Center, which we'll be talking about in the next slide. CapTIvate Design Center is basically the only tool, is actually the main tool that you would use for programming and tuning your sensors in your system. The CapTIvate mutual capacitance board also has haptic feedback. So if you want to evaluate how haptic feedback works, you can actually use the mutual capacitance board. Also, if you have your own sensors, you have your own system, really all you can do is you can connect it directly to the programmer, and you can tune your custom board or custom system, custom hardware with the CapTIvate Design Center. So it's a very flexible kit, allows you to do a lot of things, evaluate the boards that TI provides, and also create your own sensors, and also debug your own boards with this kit. Let's step in a little bit and talk about the ease of use with CapTIvate Design Center. So again, from the ground up, this has been designed to allow for a hardware engineer to go do capacitive sensing designs with almost not a line of software to be written. So here's how it goes. It's called the CapTIvate Design Center. It's an application available on Windows, Apple, Linux. We basically double-click the icon. This is what shows up, the CapTIvate Design Center. Here we want to do a slider. So we drag and drop a slider, put it in place. We go into the slider properties. We right-click on the slider menu and go into slider properties. We got to say whether you want the slider to be self mode, how many elements you want in the slider, and that's it. When you say OK, and similarly, you can have a wheel, you can have a button, you can have proximity sensors. All these are icons. You just simply drag and drop it into this canvas, and then you drag and drop the microcontroller that you're going to pick. So like I said, we have different flavors of the microcontroller. So you essentially go down there and say what device you're picking. And based on the device you pick, this tool automatically assigns the sensors to the various IOs in the most effective manner possible. So you simply click Auto Assign, and it'll tell you how to connect what sensor to what IOs. And it also takes into account that there are 4 parallel scanning blocks on the device, and it allows you to fully optimize your power consumption based on the 4 parallel scans that the device has. And here you also say what your communication interface needs to be. For instance, if you want I2C communication to the host, you say I want I2C, or you can also say UART. So based on the IO output of the CapTIvate Design Center, then you go lay out your board. So you go lay out your board, connect the sensors to the IO pins that CapTIvate Design Center recommends. And we have tons of collateral available on sensor design for you to go lay out your electrodes in the most optimal way. And then once you get your electrode board back, you come back to CapTIvate Design Center and you hit the Generate Source Code button. And once you generate the source code button, you build the code with either Code Composer Studio or IAR. Again, we have not written a line of code until now. It's all automatically generated. And then the next step is sensor tuning. So now you have your sensor board. You need the electrodes to be tuned to say how sensitive you want to make each one of these electrode pads to be. Again, do you want it to work with a light touch, with a hard touch? Do you have an overlay which you have to compensate for? And that's basically the essence of sensor tuning. So you have this graphical way of tuning it where you can have 2 thresholds. You can say, this is what I want my touch threshold to be, and this is what I want my proximity threshold to be, and you tune it using this tool. You also have various other, if you want to get to the next level of tuning, you have menus where you can simply enter what values you want here. And for each one of these parameters, a user guide just shows up when you click on it so that you know exactly what you're changing and when. So as you can see, this design, there's a video online at ti.com where we show you how to tune the sensors in 5 minutes, and this is the process you would go through. Please take a look at that video, and like I said, we have feedback from several customers saying this is one of the most simplest capacitive sensing solution for them to design with. So I would urge you to go take a look at the videos and also get yourself a kit and try it out. Next, let's step into how you can use capacitive CapTIvate technology in building automation type applications. So I picked a few very representative examples based on what traction we're getting in the market. The first example I'd like to show is an electronic lock. When you look at an electronic lock, again, these are getting very, very popular right now with the IoT and the connected home. So you want to have a keypad. So you have a keypad and it's battery operated. So you want the battery to last for a very long time. When you go with capacitive technology, it's very cool. It allows you to do really sleek designs, but the flip side of it, it's draining battery all throughout. With CapTIvate technology, we actually have a E-lock TI design. And TI design, for those of you that are not familiar with it, is actually a comprehensive design with, all the schematics, Gerber, software associated with certain end applications. So we have a TI design coming out which will basically show how to operate an E-lock at less than 3 microamps average power, getting you years of battery life. This TI design will also go through how to improve moisture rejection capabilities. Again, if it is in a wet environment where you're throwing water at it, gunk at it, how can you make it very reliable? And also, of course, there are other designs that we have which talk about ability for touch buttons to work through very thick glass. And also we have design guides which are going to come out soon on metal overlay. Metal overlay, we have not fully released all our collateral yet, but very soon you'll see applications on metal overlay. Plastic and glass is already very well available. Our EVMs actually ship with a plastic overlay, and we have this collateral available for glass overlay as well. Also, from an FRAM standpoint, ability to save the state and passcode on an electronic lock and FRAM would be an advantage when you're designing E-locks. Moving on, here is an example of a thermostat with CapTIvate. Even several thermostat applications, they need low power. In many cases, the thermostat, if you have electronics around your thermostat, you're not able to power that with the 24-volt supply that's used to control the heater and refrigeration in your house. But you need to do some energy stealing. With CapTIvate technology, because we are able to maintain this very low power, it makes it a good fit for thermostat applications. Many thermostats today have resistive. Clearly, it's very frustrating for customers to use that. We can replace that with CapTouch buttons. We also have the ability to support ITOs, which are transparent sensors. So basically, what you can do is, if you have a display, you can throw an ITO panel on top of that display where you've basically done your electrode design on a transparent substrate, right? I mean, it's not a PCB. It's a PCB, but it's transparent. You can actually look through it. And you can implement CapTouch buttons on the ITO. And when you throw that on the display, you can actually, it looks like a touchscreen controller, but it's a lower cost solution because you're just using buttons on top of an ITO, on top of a display panel rather than a full touchscreen controller. We have a TI design associated with CapTIvate and thermostats. It's called TIDM CapTIvate Thermostat UI. I have a link to all these documents in the last slide, so you can definitely take a look at that. The next target application I'd like to look at is a security panel. Again, think about a security panel provided to you by many of the popular guys like ADT or other guys. You have some kind of a keypad where you want to go enter your secret code to disarm the house. We're also seeing applications where you're using it for home automation. So, for instance, if you want to change the audio levels in your house, or if you want to change the lighting mood in your house, all that it can be done through a very, very sleek control panel with CapTIvate. So what are the advantages of CapTIvate? Clearly, we spoke about battery life, so I'm not going to talk about it again, but battery life is critical in this kind of an application. You also want to be able to use 3D gestures. What about you walk up to a panel, you start swiping left and right without actually touching any button on the panel? Maybe you have dirty hands, or maybe you have your hands filled with grocery. You want to enable applications like that. You can do it with CapTIvate technology. And with CapTIvate technology, you can have up to 64 buttons in mutual capacitance mode, allowing you to do a lot of different applications on your touchpad here. Also, like we mentioned, if you want proximity sensing and backlit LEDs, so when a person walks to the panel, you want to illuminate the panel, you can do it on the same chip using the surge capacitance mode, and wake up the system, illuminate the panel, and then you have the ability to go enter your keypad and do what you want there. We also have a gesture pad that's coming up, which will allow you to do more complex HMI. Like, for instance, you can flick up, flick down, flick right, flick left, and it sort of works like, if you have a lot of menus that you want to navigate, you can use the gesture pad with CapTIvate technology as a way to do that. So what are the featured collateral here? So clearly the 64 button is very interesting in its application. And then we also have a remote control TI design coming up. And again, please think of it as something not just for remote control, but also for applications like this where you may need some sort of a gesture pad where you want to navigate menus. Light switches, again, I was recently at CEDIA, which is a building automation show. I found lots and lots of customers and installers asking for fancy light switches. CapTIvate, you can get very, very creative with CapTIvate, again, with the ability to work through plastic, work through glass, and even wood. I mean, think about a nice panel, wooden panel, where you can actually mount the buttons behind the panel and give a really, really cool user interface. You can do that with CapTIvate technology. Again, power line noise immunity becomes important there. As I said, we have IEC 61000-4 certification. And if you look at the TI design, the TIDM CapTouch EMC rest, that will tell you exactly how you can design a system that will work for an EMC situation. And finally, elevator panels. So tons and tons of buttons on an elevator panel, both on the landing side and also inside the elevator. Again, it's a very noisy environment because you have motors and everything else running. But with CapTIvate technology, you're immune to power line noise. You can support metal touch. So metal touch allows you to actually build into the stainless steel panels of the elevator, and also if you want plastic buttons, you can also do that. And also in elevator panels, we have a large number of buttons, 64 buttons, that you can do with a single device, which is a big advantage for CapTIvate technology. So the TI designs associated with this are the 64 button, the EMC reference design, and coming soon we have a metal touch reference design also going to be available. So in summary, CapTIvate technology is very, very reliable, certified solutions for noise immunity and moisture. You can do metal touch, you can do 3D gestures, glove-friendly designs, and a very configurable solution. You can enable low power applications as low as less than 5 microamps. You have the industry's highest resolution sliders and wheels. With CapTIvate Design Center, as I showed you, you can set up your design in 5 minutes or less with a CapTIvate Design Center. There's a ton of resources available. We have videos showing how to use. Just the first video I showed is over here. It's all on ti.com/CapTIvate. So if you walk out of here with like one reference location, that's this one where we put all our collateral together. You can basically learn about CapTIvate Development Kit, how to tune your sensors with CapTIvate Design Center, how do you enable low power features, how can you implement button sliders and wheel interfaces with CapTIvate, 3D gestures and proximity sensing, moisture rejection. So we have videos for all these various things. We have TI designs that go into more details, and, providing you Gerber files and whole collateral for building all these different TI designs that you see here. And finally, we have deep dive training. These are basically our 2-hour trainings, which will go through fundamentals of PCB layout and how to go deal with EMC challenges for you to educate yourself when you're doing your TI design, when you're doing your own design. So again, thank you for your time, and I'll open it for Q&A at this time.